So today's presentation, which is looking very popular by the number of people we've got online, is challenges of ultra-deep water construction in the Black Sea. It's going to be given by Evren Ekinci. Apologies if I got that wrong, Evren.
That's good.
Of the Turkish Petroleum Offshore Technology Centre. A little bit about Evren. Evren is a chartered marine engineer experienced in installation of subsea infrastructure, offshore pipelines and offshore wind turbine foundations. He has covered project engineer, installation engineer and construction manager roles on various deep water oil and gas and offshore wind projects with Wood plc. Evren is currently the construction manager for the Turkish Petroleum Offshore Technology Centre Sakarya gas field development project. We will answer questions at the end, so everyone will give his presentation and we'll respond to any Q&As later. So without further ado, Evren, I pass over to you for your presentation.
Thank you very much for the introduction. Yep, I'll jump straight into it. I do realize there's a lot of people from this project I'm going to talk about. A couple of caveats. I've had to redact a number of things. There's a lot more we can talk about around our recent Black Sea experience. Unfortunately, I won't be able to go into everything, but I think there's plenty of interesting stuff we can talk about. So jumping into the challenges we've faced in the Black Sea in our recent expedition. So there we go. There we are. Okay, so here's part of the field layout for the Sakarya gas field development. I thought it would be quite useful to start off with this. So what we're looking at is half of the development. It's one of the drill centers. It's about 150 kilometers away from Zonguldak, which is the bigger western Black Sea towns of Turkey. It's an old sort of mining town, quite industrially developed. There are a few large commercial ports around there. One of them is Evren, the other one Zonguldak. The project was executed outside of a port called Filyos port, which was a new port. It was built for container ships, but once the gas field was discovered in 2020, August of 2020, the port was sort of converted to a sort of marine base to support all of this. So 150 kilometers, so 160-ish kilometers away, we have a 16-inch gas export pipeline. It's a tieback, so basically it's taking the gas from all this distance back to a production facility onshore. It's not the longest tieback in the world, but it's thereabouts, and it's not the deepest, but it is on one of the deepest, the probably top 3 in both categories. So it, as it is, it's a very challenging project. So the red dashed line, I don't know, can you see my cursor? Do I do this? Laser pointer. Yep, there we go.
Yes, we can. Yeah.
Now, yeah, there we go. So this red line is our export pipeline. There's a manifold here, gathers the gas. You can see red lines running out of that. They go to the wells. I've redacted the well names. Very confidential. There is an infield pipeline running to the next drill center. There are 2 drill centers, 6 slot manifolds on both of them. Then if you go down here, we've got a green line running down. There's green. This supplies glycol to the field. It's basically to manage water, to avoid getting hydrates and blocking the gas system, the gas production system. There's a MEG manifold over here. And down here, the purple stuff that goes out to the wells are the controls. We have a subsea distribution, control distribution unit over here, and that's fed by the main umbilical. Again, we've got an infield umbilical running to the second drill center. So the second drill center I'm not going to show, but it's fairly similar. It's got a distribution unit for the controls, distribution manifold for the MEG, and a gas gathering manifold to bring the gas. The reason I'm showing this, and the way I've explained this is, in a lot of oil and gas projects, we'll see a lot of these functions clustered into one large manifold, or you could accommodate the MEG with the umbilical. On this project, we chose not to do that, and that's because of this. So on the previous slide, I said it was 2020 August when the discovery was made. Quite surprisingly, the gas was brought to shore on 20th of April 2023, and I think around somewhere close to 40% capacity, the gas was actually given to the grid on the 30th of August 2023. So it's an incredible 3 years from discovery to production, and that drove a lot of the decisions in terms of how we split all that infrastructure. We thought we should buy whatever we can, bring it in country, and install it as soon as we can. So very aggressive engineering, procurement, manufacturing process in parallel with all of the drilling and completion. And then the construction, installation, and commissioning goes in parallel with the drilling and completion as well. And here's our construction fleet. Well completions were done by two rigs, two TP OTC rigs, Kanuni and Yavuz, while Fatih did the production drilling. We had a large fleet of vessels by Aras Marine working the landfall area. We had a number of light construction vessels come in, start with route preparation, start putting structures in. Two rock dumpers come in at different times. The light construction vessels were Seven Pegasus, Maersk Forza, Island Victory, and Mukavemet. And we had two large heavy construction vessels, which is fairly unusual for these sort of projects. You usually have one. Also, we had shallow water and deep water pipelay vessels. And then at one point on the project, we had 50 marine units working in the field at the same time. That would, that's including the landfall, the trunk line, umbilical, and the infield production area. So here's one of the challenges we had, not related to Black Sea per se, but the aggressive construction and drilling schedule. This is showing both drill centers. I know it's a bit messy. There's some patches there. That's where I try to hide some of the well names and all that sort of stuff. The large blue circle, this one, and this orange circle, this is actually scaled. This shows the 500-meter zone around a drill rig. And what we're looking at here, these colors are the different vessels and the different work scopes they had between the 1st of October and 1st of November 2022. So the red stuff, I believe, was 7 Oceanic. The green stuff was 7 Arctic. The yellow circles were 7 Pegasus putting structures in or doing survey. This light blue line was Castorone. This blue one was Yavuz completing this well, and Kanuni doing the lower completion of this well over here. So an incredibly busy and sort of lots and lots of SimOps to manage. I think we had a great communication and great coordination, in particular from subsea contractor side, Subsea 7 side. Yeah, it's worth noting that. Now, going on to the main activities, the subsea activities, the first major piece of work was, and probably when we started, we thought was the highest risk area for the project, which turned out to be as well, was the route preparation for the deep water pipe lay. So in order to get the route ready, we started doing some seabed excavation. And the reason we did that, I'm going to show this really useful animation that Subsea 7 kindly put together. There's our project location. That's where the port is. Our landfall area is just down there on the beach. The red line is our 16-inch production line. Green line's meg supply line. The purple one is the umbilical. And at the shelf break, after 5.5 kilometers, we go down this valley, very rugged seabeds, lots of rock outcrops. The corridor gets super narrow. We have side slopes, stability issues, free spans, variable soil properties, turbidity risks. Yeah, so KP30 is where we actually, around about KP30, we achieve the abyssal plane. It goes to the field. So that's all I'm going to show there. Going back to seabed excavation. This is scam muddering scam machine. It can basically dredge with a suction pump. It can cut rock, and it can excavate and dredge with a bucket. It's very useful. It's been super good on this project. We've used it from about 300 meters water depth all the way down to, I believe, 1900 meters. There's some video footage of the unit on the seabeds. Now, I'm jumping here to an issue that's very well known about the Black Sea. I think the reason I put this here is because the first time we put this scam machine down on the seabed, after a few dives, the way the machine works is we have the crane hook, the block at depth attached to the unit for quite long durations. And after a while, we started getting a load of black stuff on it. And that was the first indication of hydrogen sulfate and sulfate reducing bacteria. Now, the reason I put this here is the project did a lot of work to qualify all materials to, all materials exposed to the raw seawater to required hardness levels. The Black Sea is anoxic below 150 meters, so H2S is found in seawater. So wherever we had high grade steel, whenever we had cold form material, etc., there were significant and particular hardness requirements. But obviously, there are small things that sometimes get forgotten about, and this is one of them. So this is the manifold valve indicator. You can see the as-built status on the left. You can see the O for open and S for shut. And a few months later, you can't see either of them. Okay, here's some footage of scam machine working subsea, cutting rock. I think we achieved something between 1 meter cube or 2 meter cube an hour, which is quite impressive. At some point, we shaved off features that could pose risk on pipelines that could get unstable. Other stuff on scam machine, I think it's worth noting. If we could have had earlier engagement with survey and site investigation, we probably could have done a lot better. I think the grab system worked really well. We had a grab on deck. We plotted the grab on overlays. In the future, it would be good to have grabs that don't require ROVs, that can scan the seabed. That's an improvement we should pursue. Okay, this is showing the areas we worked at. We've done rock cutting, probing, grabbing. We've used the subsea dredger. We've used the subsea bucket. We've done some rock splitting trials and grab. And as a result, we've been able to reduce what could have potentially been a 1 million-ton rock dumping campaign. And we got away with that. And instead of that, we excavated about 20,000 meters cubed of rock and soil and managed to get away with not using this vessel as much as we originally planned. So this is the Storness, I believe, moored alongside in Philios, loading rock. She did the prelay rock installation, so she filled in some gaps in order to prevent unacceptably long spans. She dumped about 190,000 tons. Then for the post lay, where we covered some of the trench and some further corrections, Simon Seven dumped 150,000 tons of rock. And finally, at a later add-on campaign following a earthquake and turbidity event, the Storness came back to dump 156,000 tons of rock. So it's worth noting for both Van Ord and Jan de Nul, these contractors have excellent engineering capability for sort of subsea rock installation. Yeah. Okay, going on to pipe lay. Shallow water was done by Castoro 10. She's an old one. Moored over here. I think it's worth noting this. This is the landfall route, that yellow line. So once the pipeline follows north from the onshore processing facility, does a couple of bends, and then it's an acute angle running across the river mouth, Philios river mouth. And this proved really difficult. So here we see the cofferdam for the pipeline. So we had a single cut trench for production and megline. So two pipelines lying in the same trench. And really had difficulty maintaining the trench over the course of the shore pull for both of these lines, mainly because we had a huge amount of rainfall. One particular incident where I think we had what corresponded to maybe a 100-year rainfall amount coming out, river flow amount coming out of the Philios River. Deep water pipe lay was done by Castorone. Yeah, we did have issues with Castorone, but in the end, it was finally a successful campaign. Some field joint coating damage that was sort of repaired and handled. One interesting incident, which is related to this rainfall and flow event, was that the LBL array, the sparse array that was built down the escarpment to negotiate those narrow corridors and tight root bends and proximity to side slopes, etc. The sparse array that allowed us to install the pipeline at higher accuracy than conventional pipeline, I'd say, very narrow corridors. Basically, the transponders that built that array came down with the turbidity flows due to the river flood event. When Castorena came out to start the pipe lay, she basically couldn't find the built array. So that was a lesson in a number of things. looking at slopes we position those arrays on, the type of frames or sort of buoyancy and weight we use to position them, and possibly being more rigorous in terms of checking the function and the health of the array. Okay, 7 Pegasus put down these large mud mats. They are very large mud mats. The soils in the deep section of the Black Sea, well, you don't really know where it starts or ends. It's so weak at the top layers. We had very large mud mats, but this particular one also has piles. So you can see on the top left over here, the pile lifted, and then the pile being slotted into its receptacle. It was driven by clump weights. And the soils are so problematic that we need these piles to mitigate for risks associated with seismic events. So there was a risk that seismic events could cause liquefaction and sinking of the structures in these soils. So that was interesting. This is the Arctic. The Arctic did all the heavy lifting. So she put in the foundations for the manifolds, put in the manifold top modules, long flexibles. Yeah, and then she also performed a major repair scope for us towards the end of the campaign, which I'll give a bit of detail on. Okay, this is a photo of the nearshore section of the longest umbilical in the world. This is the 30-kilometer section running from the beach to KP30, just being packed nicely in the carousel. Unfortunately, this umbilical was packed on the carousel twice, and that was because of this earthquake event. So the earthquake occurred in a place called Düzce, maybe about a couple of 100 kilometers away from the landfall area. And I think it says suspected landslide start here, but there is a sediment reservoir over here that was probably dormant for a while, and an earthquake of 6.2 on the Richter scale triggered turbidity flow down this channel, and it basically hit all these lines nearly perpendicular, dragging them across. Obviously, there's a lot of rock outcrop over here. The pipeline's shifted, but this green line, which is the umbilical dragged all over the pipeline, and it found itself at the bottom of this canyon wall. It was heavily damaged. I think we lost 2 electrical quads. We lost about 16 or 18 fibers, at least 1 or 2 tubes. But before I go into that detail, I should probably explain what the umbilical system looked like. So this was the shore side, and this is the bottom as the production end, the field end of the umbilical. We had a 30-kilometer section, which was laid by the 7 Oceanic, and we had a 140 odd kilometer section laid by the Arctic. Now this the reason we built it like this is we did not want to put in an inline connector, and we decided to build this with a double UTA unit and connecting using sort of flying leads, which are sort of more simpler cables, I would say. That's probably in layman's term. It's just basically using cables at these structure interfaces. And the reason this was 140 kilometers is because that's the size of the Arctic carousel, which I believe is the biggest in the world. And this made this umbilical the longest umbilical system in the world. Yeah, so the damage obviously occurred over here around 650-meter water depth. And here's some underwater photos of the damage. You can see it's almost completely severed here. There were a lot of sort of superficial cosmetic damage all over it, going down to about KP20. So the way this was fixed is that 30-kilometer umbilical was basically picked up from the UTA about 25 kilometers back to where it was buried at the top of the escarpment. It was basically put back into the carousel, and as it was recovered, the sort of cosmetic, the easily repaired stuff was repaired, patched up. Then the damaged section was grabbed just below the tower with a grab tool, and there was a cut made above it. Then the damaged section was pulled up. There was another cut made underneath. The damaged umbilical was sort of scrapped. The shallow end of the umbilical was temporarily laid down, and the rest of it, about 25 kilometers, was taken to port. At port, on the deck of the Arctic, a special habitat was built for splicing, fusion welding, and eventually what we see here is an inline joint, which basically was a repair joint, a pod. All the functions were recovered, welded, connected, and put back in. And the pod was negotiated over the lay tower and laid back onto the seabed. The umbilical was laid all the way back to its original position at that WTA assembly. So this was a very interesting repair program. I personally have not heard of such a repair being executed in this sort of water depth. It was very well planned, and I think we should give credit to Subsea 7 in particular for having the inline repair joints ready, preparing all the technical workforce, and putting in the engineering to reverse all of this and put it back in. And it's worth saying that everything that was repaired on this inline repair joint is fully functional and it's still functional. So job really well done. Now, this slide I put in a few hours ago. You'll see the date, February 5th, 2025. I can tell you that this has not really changed since sometime in April 2023. So since April 2023, we've had an incredible amount of GPS interference in the Black Sea. This is most likely to do with the ongoing conflict between Russia and Ukraine. And we get GPS jamming on a daily basis. Initially, it was really hurting us. So we went and invested in various different anti-jamming systems, which sort of uncovered that not one system works for all vessels. In fact, it's going to be a customized system for every different vessel. And now we operate with, I think Castorena is laying right now. Within the last 2 weeks, she had 2 events where she went down to a single antenna, but still able to lay because of the anti-jamming systems that she's installed. And also when we go and do longer subsea installation operations, we sort of behave like a drill rig and put down DP arrays for the vessel to work around in, so that if we do have GPS outage, as a minimum, we can get into a safe condition and we don't have sort of vessel drift off and risk the subsea infrastructure. Okay, now this is my last slide. I think this is important to note. unless there's a major construction going on, there aren't many subsea assets in the Black Sea that can do heavy duty subsea construction work, interventions, you know, putting a few tons of load onto the seabed. In the Black Sea at the moment, significant cranes we know of. There are 5 cranes. One of them is a tiny little one on one of the vessels that inspect one of the other pipelines in the Black Sea, and the rest are all on the TP rigs and this vessel over here. So it is quite important that this capability and regionally has to improve. So there will be more projects, there will be more phases, and there'll be more assets operating in the region. So more vessels with craneage, more vessels with high quality work class ROV support, DP2, DP3 definitely required.